My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Object-Oriented System Development as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: what is UML? UML, Unified Modeling Language, is a standard way to visualize, design, and understand an object-oriented software system before writing the actual code. It works like a blueprint for software, just like engineers draw building plans before construction. In object-oriented system development, we deal with objects, classes, relationships, and interactions. UML helps us show all these things using diagrams so that developers, students, and even non-technical people can easily understand how the system works. Why UML is useful? Simple words. It makes the system clear and organized. Helps in finding problems before coding. Makes communication easy among team members. Saves time and cost. Example. Imagine you are making a college management system. Using UML, you can draw a class diagram showing class student, attributes name, role no, course, operations register, pay fee. This diagram gives a clear idea of how the student object will behave in the system. UML makes software development easy, visual, and error-free. Next important short question is: to define class. A class in object-oriented system development is a blueprint or template used to create objects. It defines what an object will have, attributes, and what it can do, methods. Think of a class like a recipe. A recipe tells you the ingredients and steps, but it is not the actual dish. Similarly, a class describes the structure and behavior, but it is not the actual object. Simple meaning. A class is a model that describes a group of objects having similar properties and actions. Example, easy to understand. Consider a student class. Attributes, data name, roll number, department, age. Methods, actions attend class, submit assignment, write exam. From this one student class, we can create many student objects like Ravi, Priya, or Arjun. Each object will have different values, different names, roles, but they all share the same structure because they come from the same class. So, a class helps us design software in a clean, reusable, and organized way. Next important short question is: 3. List the relationship used in class diagram. In a class diagram, relationships show how one class is connected to another. They help us understand how objects work together inside a system. The main relationships used in class diagrams are: 1. Association. A simple link between two classes. Example, teacher teaches student. 2. Aggregation. A whole part relationship, but the parts can exist independently. Example, a library has books, books can exist even without the library. 3. Composition. A stronger form of aggregation where parts cannot exist without the whole. Example, a house has rooms, if the house is destroyed, rooms also disappear. 4. Inheritance generalization. One class inherits properties of another. Example, car electric car is a type of car. 5. Dependency. One class depends on another temporarily. Example, a student depends on a printer to print notes. These relationships make software design clear, meaningful, and easy to understand. Next important short question is: 4. What is component? Give an example. A component in object-oriented system development is a small, independent part of a software system that can work on its own and can also connect with other components. It is like a building block used to create big applications. Each component has a specific job, and all components together make the complete system. You can think of a component like an app inside your mobile. Each app does something different, one for music, one for WhatsApp, one for payments. Similarly, in software, each component does its own task. Simple meaning. A component is a reusable unit that provides some functionality. Example. In an online shopping system, we may have components like login component handles user login. Payment component processes payments. Product catalog component shows list of products. These components are separate, but when combined, they make the whole shopping system work smoothly. Components make software easy to build, reuse, update, and understand. Next important short question is 5. What is generalization? Generalization in object-oriented system development is a relationship where a child class, subclass, gets the common features of a parent class, superclass. It is used when many classes share similar properties and we want to avoid repeating the same code. Simple meaning. Generalization means is a relationship. A child class is a type of parent class. It helps us write clean, reusable, and organized code. Easy example. Imagine a parent class vehicle with properties like speed, color, move. Now, we can create child classes. Car is a vehicle. Bike is a vehicle. Bus is a vehicle. All these subclasses automatically get the common features of vehicle, but they can also add their own special features. For example, car may have airbags, bike may have kickstart. Generalization makes software simple, reusable, and easy to expand. Next Unit 1. Long questions. First important long question is 1. What are the building blocks of UML? The building blocks of UML, Unified Modeling Language, are the basic elements used to design, understand, and communicate an object-oriented software system. They act like Lego blocks. We join them to create the complete system model. UML has 3 main building blocks. 1. Things, elements of UML. These are the main items that appear in diagrams. They are divided into 4 types. A. Structural things. These show the static part of the system, things that do not change often. Examples. Class, student, teacher. Interface. Component. Node. B. Behavioral things. These show how the system behaves. Examples. Interaction, communication between objects. State machine, how an object changes states. C. Grouping things. Used to organize and group elements. Example. Package, like folders in a computer. D. Annotational things. Used to give comments or explanations. Example. Notes, sticky note symbol in UML diagrams. 2. Relationships. Relationships show how things are connected. They are the backbone of UML diagrams. Main types. Association, simple link, teacher teaches student. Aggregation, whole part, library has books. Composition, stronger whole part, house has rooms. Generalization, inheritance, car is a vehicle. Dependency, temporary use, student uses printer. Relationships help us understand how classes and objects work together. 3. Diagrams. Diagrams are pictures made using things plus relationships. They help us visualize the system easily. Important UML diagrams: class diagram, object diagram, use case diagram, sequence diagram, activity diagram, component diagram. Example: in a hospital management system, a class diagram may show class patient, class doctor, relationship doctor treats patient. Easy to remember trick: UML building blocks is equal to things plus relationships plus diagrams. Think of it like what? Things, how connected. Relationships shown as diagrams. These building blocks make UML clear, structured, and easy to understand. Next important long question is: 2. Write a short note on structural modeling. Structural modeling in object-oriented system development is all about showing the static structure of a software system. Static means the parts of the system that do not change frequently, such as classes, objects, attributes, and relationships. It answers the question, what are the main building blocks of the system? Structural modeling is like drawing the map of a city. Just like a map shows roads, buildings, and areas, structural modeling shows the classes, objects, and how they are connected. Key elements of structural modeling. 1. Class. A class represents a group of similar objects. Example: student, teacher, course. 2. Object. Objects are real instances of classes. Example: a student named Arjun is an object of the student class. 3. Attributes. These define the data stored in a class. Example: student has name, roll no, and department. 4. Operations methods. These define what a class can do. Example: student can attend class, write exam. 5. Relationships. Relationships show how classes are connected. Types include association, aggregation, composition, generalization, etc. Why structural modeling is important? Helps visualize the architecture of software. Makes system design clear and organized. Reduces confusion among team members. Helps identify missing or unnecessary elements. Forms the foundation for all other UML diagrams. Main diagram used in structural modeling. Class diagram. This is the most important structural diagram. It shows classes, their attributes, methods, and relationships. Example: for a college management system, the structural model may include class student, class faculty, class course. Relationship: student enrolls in course, faculty teaches course. This gives a complete picture of how the system is built. Easy to remember trick. Structural modeling is equal to what the system is made of. Behavioral modeling is equal to what the system does. Structural modeling helps build software that is organized, clear, and easy to develop. Next important long question is: 3. What are the relationships in UML? In object-oriented system development, relationships in UML show how two or more classes, objects, or components are connected. They help us understand how different parts of the system work together, just like understanding relationships between people helps us understand a family or a team. UML mainly uses 5 important relationships, each with a simple meaning. 1. Association. A basic connection between two classes. It tells that the classes are linked in some way. Example: a teacher teaches a student. Teacher left and right arrow student. 2. Aggregation has a relationship. A whole part relationship where the part can exist even without the whole. Example: a library has books. If the library closes, books can still exist. 3. Composition. Strong has a relationship. A stronger form of aggregation. Here, the part cannot exist without the whole. Example. A house has rooms. If the house is destroyed, rooms also disappear. 4. Generalization. Inheritance is a relationship. Shows that one class is a specialized version of another class. Example. Car is a vehicle. Car inherits features like speed, wheels, engine, etc. 5. Dependency. One class temporarily depends on another for some work. Example. A student depends on a printer to print notes. Without the printer, student cannot complete that task. Why relationships are important? They show how different classes communicate. Make the system realistic and organized. Help reduce code repetition. Useful for designing class diagrams and object diagrams. Easy memory trick. Remember the code AACGD. Association. Aggregation. Composition. Generalization. Dependency. These relationships together help us understand the complete structure of an object-oriented software system. Next important long question is: 4. Explain about interfaces. Discuss its types and roles. In object-oriented system development, an interface is like a contract or agreement between classes. It defines a set of methods that a class must implement without specifying how they work. Think of it like a remote control. It tells you what buttons exist and what they do, but it does not tell you how the TV works internally. Simple meaning. An interface is a blueprint for classes. It only contains method names, signatures, not the actual code. Any class that implements the interface must provide the behavior for all methods. Types of interfaces in UML. 1. Provided interface. The interface that a component or class provides to other parts of the system. It shows what services it offers. Example. A payment component provides a pay interface for users to make payments. 2. Required interface. The interface that a component or class needs from others to work properly. It shows what services it requires. Example. A shopping cart component requires a payment interface to complete checkout. Roles of interfaces. 1. Define rules. Specifies what methods a class must implement. 2. Promote reusability. Different classes can implement the same interface in their own way. 3. Enable loose coupling. Components can interact without knowing internal details. 4. Encourage standardization. Ensures consistent behavior across the system. Example, easy to remember. Suppose we have a vehicle system. Interface, vehicle interface methods, start, stop, honk. Classes implementing this interface, car, bike, bus. All these classes must provide their own start, stop, and honk methods, but the interface ensures a standard way of interaction. Easy trick to remember. Interface is equal to contract blueprint. Provided is equal to what I give. Required is equal to what I need. Role is equal to rules plus reusability plus loose coupling plus standardization. Interfaces make software flexible, organized, and easier to maintain, which is very useful in object-oriented development. Next important long question is: 5. Discuss about packages. Explain with example. In object-oriented system development, a package is like a folder that groups related classes, interfaces, or components together. It helps organize the system and makes it easy to manage, understand, and reuse. Think of it like organizing your study notes in different folders: math, science, history. Each folder contains related files. Simple meaning. A package is a container for UML elements. It shows logical grouping, not physical location. It makes large systems structured and easier to navigate. Why packages are important? 1. Organize system helps break a large system into smaller, manageable parts. 2. Reduce complexity. You can focus on one package at a time. 3. Promote reusability. Packages can be reused in other projects. 4. Control visibility. Only necessary classes can be exposed outside the package. Example, easy to remember. Imagine a college management system. We can create packages like 1. Student package. Classes, student, attendance, exam. 2. Faculty package. Classes, teacher, salary, timetable. 3. Library package. Classes, book, issue, return. Each package contains related classes. For example, the student package manages everything about students, while the library package manages books and transactions. Packages make it easier for teams to work on different parts without interfering with each other. Visualization in UML. In UML diagrams, a package is shown as a tabbed folder symbol. Inside the folder, you can put all classes, interfaces, and components that belong to that package. Easy trick to remember. Package is equal to folder of related classes. Just like folders organize files, packages organize classes and components. Helps manage complexity, reuse code, and maintain large systems easily. By using packages, software development becomes structured, efficient, and easy to maintain, which is very important for object-oriented systems.